In this case, what we've got is, so we've got a sample of magnesium sulfate, hydrated magnesium sulfate that's been weighed, and the mass has been found to be 14.24 grams, right? And later, the anhydrous sample of the magnesium sample has been found to be 6.14 grams, and we need to find out the value of X. So how are we going to go about figuring that out? Well, in this context, what does X actually represent, right? So X represents the question of really, the answer to the question of, well, for every 1 mole of MgSO₄, how many moles of H2O are we going to have in the, effectively in the hydrated sample, right? And this is, X is going to need to be, first of all, X is going to need to be an integer value. But beyond that, that question is really a question concerning amounts of substance, right? But what we have in, as far as the data we've been provided, it much more leans towards masses, right? We've got masses here, but we don't have actual amounts of substance in the way that's easy to compare, right? So we're going to work to make that easy to compare by converting the relevant values to moles, right? And how are we going to do that? Well, the equation I'm going to use is that the number of moles N is equal to the mass M divided by the molar mass Mr, right? And so in this particular case, we've got 14.24, right? So that's actually 14.24 is the hydrated sample mass. What I'm going to do is I'm going to focus first on the MgSO₄, right? So for MgSO₄, the mass of that once the water is removed is going to be the 6.14 grams. So therefore, if I'm going to say, well, the number of moles for MgSO₄, right, that's going to be 6.14 divided by the mass of, divided by the molar mass of MgSO₄. So I do need to work on figuring out the molar mass of MgSO₄. So if I say, well, the molar mass Mr of MgSO₄ is equal to what, right? So I've got some of the excerpts from the periodic table here. I also do have the a bit more. So what are some of the relevant elements here in this question? So magnesium, sulfur, oxygen, right? Okay, so for magnesium, that's going to be 24.3 and it occurs once, so 24.3. So that's the relative atomic mass, right? So plus sulfur, 32.1, that occurs once, and O4, so that's oxygen, that occurs 4 times, O4, so it's going to be 16 multiplied by 4, right? And so that's going to be 120.4, right? And that's going to be in units of grams per mole, right? Okay, so I'm going to use that value, so 120.4, right? And what's that going to give us? That's going to give us 0.050997, right? And that's going to be in moles, right? And I also want to have the value of, the number of moles of the H2O, because we want to be able to compare them so we can really sort of figure out what X is going to be in this. Now, to do that, we're going to need the mass of the H2O, which is not given directly in the question, but we are given the other two masses. Now, the anhydrous sample mass is simply the mass when water's all been removed. Therefore, to figure out the mass of the water, we can just do 14.24, the hydrated mass, minus the minus 6.14, which is the anhydrous sample mass, right? So mass for H2O is going to be 14.24 minus 6.14, right? And what's that going to give us? That's going to give us 8.1 effectively. And that's going to be in moles. All right. Now, no, it's not going to be in moles. That's going to be in grams. 8.1 grams. Okay, yeah. So then, as far as actual moles, so the that's going to be n, right? So number of moles for H2O, right? That's going to be our mass, 8.1 divided by the molar mass, right? So you may know what the molar mass of H2O is, but in any case, if you look at the periodic table, you find you've got so H2O, so that's going to be 1 times 2, so it's relative atomic mass of hydrogen times 2 plus 16, right? This is the number, this is the molar mass MR of H2O plus 16, which is equal to 18, right? And that's going to be grams per mole, right? So it's going to be 18. And so if you do that calculation, you should find you get 0.45. And yeah, this is actually going to be in moles, right? So 0.45 moles. So you've got two different values here, right? And what I'm going to do, as you can see, MgSO₄ is on the left hand side, so I'm going to set up a ratio between the two, and I'm going to make sure that that kind of conventions follow. I'm going to keep the MgSO₄ on the left hand side. So number of moles of MgSO₄ in ratio comparison with the number of moles of H2O. And so for MgSO₄, what do we have? We've got 0.050997, and for H2O we've got 0.45, right? And remember, what we've got here as far as X is we're asking again, the question is, for every 1 mole of MgSO₄, how many moles of H2O? Now, it's not easy to answer that question when the value for the number of moles of the MgSO₄ is not 1, right? So I want to get that to 1 to address that question, but how am I going to do that? Well, I'm going to divide it by itself, right? So if you divide it by itself, you're going to get 1. So I'm going to divide that by 0.050997, right? And that's going to give us 1, and that's going to be in the ratio of, well, we've got to divide the 0.45 by, again, 0.050997, right? And that is going to give us 8.8240, right? Now, we're going to need to round this to the nearest integer value. As I mentioned before, X is an integer value. And what does 8.8 round to? Well, it's going to round to 9, right? So, in effect, 1 is in a ratio with what is approximately 9, right? And therefore, we're going to say X is equal to 9, right? And therefore, the formula in this case is going to be MgSO₄, right? And 9 H2O, right? And yeah, so in this case, the value we're going to have here is 9, right? Okay.